Question number 3. This is another example that we're going to use KVL and KCL. This question was given to me by one of the students, and I thought I'm going to share the solution with everybody. That's a good example, indeed. Okay, so we have a voltage source here. We have a current source whose current is unknown. We actually want to find IS, the value here. And some of the parameters are given, for example, 4 ampere, negative 2 amp there. We have a bunch of resistors, and we would like to solve this circuit basically. Specifically, we want to know what is IS. Okay, so first when I look at the circuit, I will look at the things that I know and try to take advantage of those information. So I know, for example, 4 amp is going here. So therefore, if 4 amp is going here, definitely there will be also 4 amp here, because as we know, things that are in series and whatever the elements are, doesn't matter, the currents will go basically, they will have the same current when they are exactly in the series. Okay, so therefore this branch basically has 4 ohm in it. And then on this branch, we have negative 2 amp on this direction. So when that negative 2 amp is going to this direction, it means that 2 amp is going in the other direction. And honestly, we prefer to work with positive numbers than negative numbers, right? So therefore, I would just change the direction so that I will work with a positive number. So I would say 2 amp is going this way. And again, because these are all in series, therefore there's another 2 amp going this way. And on this one, on the 9 ohm, also 2 amp going this way, okay? So 2 amp in this here, 4 amp there. Okay, so now look at this node here, node A, if we call it node A. Easily we can write the KCL here and find the current here. If let's call this I1. You can either look at it by just looking at it. You say 2 amp going out, 4 amp is going out, therefore 6 amp has to go inside the node. Or you can just formally write KCL at node A. And you can say the current out 2 plus 4 minus I1 equal to 0. Because I1 is going inside, so we have to change it to negative. In general, all the currents out plus and the currents in minus. So 2, 4, and then minus I1 equal to 0. In other words, I1 is equal to 6 amp. Okay, very good. So 6 amp is going this way. Okay. Now let's write a KVL on this loop. Because a lot of currents are here known. By doing KVL, we can find more currents. And also let's call this current here also I2, because we don't know this current, I2. This is I2, this was I1, which was 6. Okay, so let's write the KVL. So KVL on this loop. I star doesn't matter really where to start. Let's start from here. 11 times 2. See, Ri, V equal to Ri. I'm doing the law at the same time. Ri, and then plus 10 times 2. 10 ohm times 2 amp. And then I reach here, the 30 times I2. Then plus 5 amp times 6, 5 ohm times 6 amp. And then finally 9 times 2 equal to 0. Remember, you have to come back to this. So we basically 1, 2, 3, 4, 5. So we met 5 elements. 1, 2, 3, 4, 5 equal to 0. And this way I can find I2. In this equation, the only unknown is I2. So let's do the math. So this was 22. This is 20. This is 30, and this is 18. Okay, so basically 42 plus This is 42. I have a 30 and I have an 18. 30 and 18. And then I have 30 I2 equal to 0. So 42 plus 18, 50, 60, and then 30, 90. So this is 90. 90. So I2, 30 I2 equal to negative 90. So I2 is negative 2, right? Negative 2 amp. Very good. So therefore I2, we can write here negative 2. Okay, very good. So now IS is unknown, right? We wanted to find IS. Let's write the KCL here. At node, let's call it B. So KCL. The KCL at node B. The current out, IS. I1 plus I1 is out. IS I1 equal to, negative I2 equal to 0. So here, don't care about if I2 is itself is positive or negative. We are working with the symbols, okay? I1, I2, IS, and they have some directions. So the current out, which is 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 going out of the node B. I1 is going out. So they're plus, and then for I2 is going inside, so it's minus equal to 0. Okay. So you can either say this, or you can say, I don't know, current in, current out. So I2 is going inside, and then I1 and IS going out. However it works for you, but you can write like this. So IS plus I1. Now I1, whatever the value it has 6, minus whatever I2 has, which is negative 3 equal to 0. So minus and minus plus, this becomes 9. So IS equal to negative 9. Okay, very good. So going back to this figure, so we find out that IS is negative 9. Okay.